So in this video, I'll discuss why the variance or standard deviation sometimes uses n-1 in the denominator instead of n. So just using an example with standard deviation, but keep in mind that this rule can be used for either standard deviation or the variance. So it would just be sum of the deviation squared over n. So that's the notation that you're used to. But sometimes you have to use n-1. So the question is, why? Well, thinking of the first case, n is used whenever you have an entire population of data, or a complete data set, I guess is another way to put it. So for example, if we wanted to know the heights of everyone in Canada. So you would collect all the heights of everyone in Canada. So therefore you would have the heights of the entire set. So in other words, the data set that you have is complete. So in that case, you're able to use the normal formula for standard deviation. So you just divide by n because your data is complete. And so therefore the standard deviation or variance that you get is the actual standard deviation or variance for that population. On the other hand, if you don't have complete data, or you simply use a sample, so this would be if you use a sample or incomplete data. So for example, in most cases it is impractical to determine the heights of everyone in Canada, so it's like 35 million people. Instead you would use maybe a sample of 100 people, and obviously that sample should try to be representative of everyone in Canada. So in that case, it's clear that the data that you have is incomplete. And so in that case you use n-1. So why? Why do you use n-1? Well, because when you use a sample of a population, the variance or the standard deviation that you determine is not the actual or real measure of the variability. In fact, it's an estimate of the variability, because you don't, I mean, it's obviously an estimate because you can't determine the actual variance or standard deviation with just a sample. And so what happens is when you have a sample, you're not able to capture all the variance. And the reason being, if you think about it, is if you want the heights of everyone in Canada, there's going to be a great deal of variability because there's so many people. So some people might be extremely tall, like 7 feet tall, and some might be short, so they might be like 3 feet tall. And so those are some extreme scores within your distribution. But when you have a sample, there's less of a probability of capturing those extreme scores, because chances are you're not going to get someone who's 7 feet tall or someone that's 3 feet tall. So in effect, what happens is your variability is decreased because there's not as many, the spread of the scores is not as extreme. And so what you say is that the standard deviation of the variance is smaller. And so in order to account for that decreased variability in general, is you need to somehow make the term bigger. And so in order to make the entire term, the entire standard deviation or the entire variance larger, is you divide it by n-1. So if you think about that for a second, so for example, if you're in general, so say for the standard deviation, or let's use variance instead. So for variance, you get the numerator is 5, and then maybe you used only 2 people. Well, and that was the entire population. Well, you would get a variance of 2.5. But now instead, say that the variance that you have isn't actually, the entire population isn't 2 people, but you have a sample of 2 people. Well, in this case, you're going to have to subtract it by 1 because it's just a sample. And so that would make it 5 divided by 1. And that gives you a larger variance. So by dividing it by a smaller number, in effect, it gives you a larger value. And that's why you divide by n minus 1 when you have a sample rather than the entire population. So I hope that made a little bit of sense. Thanks for watching.